Greetings! Welcome to Lab 1, and this is an assignment 2 from Chapter 1. It's 3.3 in Module 3. So you've hopefully navigated to the assignment and you've come to this part and you've seen that you are to do Lab 1. So I'm not going to go ahead and read that to you. I'll let you do that on your own. But I do want to show you a couple things before we actually get started. So first off, you want to go ahead and open up the RMD template to help you with this assignment. So I'm going to click on that and say OK, and notice it'll open up an RMD for me. Now I'm going to actually do the vast majority of this lab down here in the console, but we'll have the RMD ready to go for our use also, okay? And if you want, you notice the change of the cursor there, you can slide the console up a bit so you can see more of the console. Okay, so let's go back into Firefox. I'm going to scroll down. A very important thing we're going to want to do is open up the HTML version of this lab, so we'll click on that. And now that opens up a HTML file for us, which is great. We want to have that. We want to have that open while we're working the lab because we're going to cut and paste the commands from here into the console while we're working the lab. If you have not yet done so, go ahead and stop this video and read the introduction and the getting started. And then once you've done that, come on back. Okay, so if you've read that, you see that this is a huge data set. It is a subset of 20,000 from a sample of 350,000 from the CDC. It's the BRFSS, which is the Behavioral Risk Surveillance System, or Behavioral Risk Factor, surveillance system that the CDC creates. It's a massive data set. So this is taken from the year 2000. It's 20,000 of those actual data samples. So our first step is to get that loaded into our workspace. So to do that, we're going to come in here and we're going to copy that command. So copy that, and then we're going to come back over here into R, and we're going to go ahead and paste that directly, whoops, not into our markdown, sorry about that. I want to put it down here into the console. So once I've got it in the console, I'm going to hit an enter. And you see a little stop sign there that says, hey, R is working, don't touch me right now, leave me alone for a moment, because it's a lot of numbers you asked me to import. So it's downloading, full 20,000 data points, which is quite a bit. There we go. So now we've got the CDC data installed. We see that just showed up in our environment. If you want, you can click on that, and over here up above, it'll show us a version of it, which is really nice. I mean, that's a beautiful thing. But we can also see the CDC by using what's referred to as the head command, and that allows us to take a look at just the top. But before we do that, let's do what they ask us to do in the lab, and they ask us to take a look at the names of the variables. So you can either cut and paste that command in, or you can type it in, whichever way you'd like to do that. So I'll just cut and paste it, and if I hit an enter, notice that it go ahead and gives me the names of my variables. So we have in this data set, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9 variables. There's general health, there's exercise, any health plan, smoke 100, height, weight desired, age, and gender. So I'll have you read up about what those different variables, what they represent. There's a nice write-up in the lab here, but we're going to go ahead and work with just a few of these variables at a time. But before we do that, just a quick review of the variable type. One of the things you can see up here when we typed in the view command by clicking over here in the data is that each of the data are of a different style. In other words, this data matrix or this data frame is made up of categorical data and quantitative or numerical data. So for example, general health, if we take a look at general health and we sort of scroll through here, it takes on the values of good, very good, excellent, fair. So those are words responses. So that is a categorical variable. Then there's exercise any. So have you exercised any in the last month? Well, a 0 it represents a no, and a 1 represents a yes. So even though those are numbers, those are actually categories again. So it's just they're being codified into numbers. Same thing over here with a health plan. Do you have a health plan or not? A 1 is a yes and a 0 is a no. Have you smoked over 100 cigarettes in your life, okay, during your life? And a 0 is a no, and a 1 is a yes. And then now we're going to switch to a quantitative data. So now height, that's a quantitative data, and it's also a continuous quantitative variable, because height can be any value within, the continuum of reality there, where obviously we can't have somebody whose height of 0 or height, say, of 100 feet. Those wouldn't make sense. But nonetheless, the height in inches is reported there, and then the weight in pounds, that's reported, and the weight desired is reported. So all of these variables, the height, the weight desired, and the age, those are all quantitative continuous. Now you may be tempted to say that age is quantitative discrete, but that's the way we choose to measure it, is in years, but the reality is age is time, and so that is a continuous variable. And then we come back to gender, which is, again, is a categorical variable, because you're either categorized as being male or female. Okay, enough of that review. Let's get on with the lab. So first thing they say is that we can look at just the first few entries or rows in the data by the command using head CDC. So let's type that in. So head, and then we'll put in CDC. And notice again, it repeats pretty much what I did when I clicked on the data set up over here, and it displayed it for me up above. Okay, so again, nice display, beautiful, but let's move on. Okay, so one of the things that we'd like to do is take some of the data and summarize it. Now we'll start off with summarizing numerical data, and then we'll talk about how we would summarize categorical data. So let's take a look at the weights, and let's go ahead and see what we can get in terms of a summary of the weights. Now what we mean by a summary is we'd like to take a look at the summary of the numerical values. And so the numerical values of the weight, we'd like to find out what is the mean, what is the median, what is the min, what is the max, what's Q1, Q2, Q3, etc. Okay. Now you might be tempted to just type in summary weight. Okay. But the problem is, if I hit an enter on that, which I'm not going to do, it's going to bark at me, because notice, at least in the autocomplete here, we're not seeing what we wanted, which is data. It's all coming back with commands, and that's not what we wanted at all. We wanted the actual data. Well, remember that what you need to do is you need to drill down into the data frame, and you need to tell it, first of all, that I'm in the data frame CDC, and within that data frame I want weight. Okay, so don't forget that. That's an important thing. All right, so now it gives me back the minimum, it gives me back the first quantile, the median, which is the second quartile, the mean, the third quantile, and the maximum. Now I can, if I choose to, I can go ahead and calculate the interquartile range by simply using RStudio as a calculator here. I can just go 190, subtract 140, and if I do that, I get about an interquartile range of 50. Nice thing is that the IQR is also built in. I can go IQR in capital letters, very important, you have to use capitals, CDC, $, and then weight. And if I hit the tab, it'll do autocomplete for me. And notice it gives me the exact same number. Okay, that's pretty cool. All right, now we can also peel off individual summary statistics from that summary table, and also get the standard deviation, because you notice one of the things is that summary did not give us the standard deviation. Okay, so let's go ahead and just get R to give me back just the mean. So we'll go the mean of CDC, $, weight, and notice it gives me back the same number that we had a minute ago up above. The difference being here is that since it only went out one decimal place, it's rounded off. If I do it to the console directly, it's going to give me back 3 decimal places. Okay, what if I want to know the standard deviation? Well, standard deviation is a bugger to do by hand. We would never want to do that by hand, particularly with 20,000 data points. So if I type in SD for standard deviation and then put in CDC, $ weight, I get back that the standard deviation is 40. Quick interpretation of what we mean by the standard deviation. Remember, the standard deviation is the average distance away from the mean. So that means on average that the data points, the weights, are spread around about 40 pounds above and below the mean. Excuse me. So keep that in mind. That's important. Make sure that you have that in your reference book, what the definition of the standard deviation is. Okay, one more. Let's take a look at the variance. The variance is the standard deviation's older sibling is one way of thinking about it. It's simply the standard deviation squared. And we will talk more about that as we get further in the course. So in other words, if I took the SD, the standard deviation of CDC, of the weights, and I squared that, I will get back the exact same thing as if I did the variance, okay? So just keep that in mind. The variance is the standard deviation squared. Another important thing to write down in my comp book. Okay, so let's do the median just so we can show that it happens. They asked us to do that in the lab anyway. So the median of CDC and then the weights. And again, we get the same thing that we did in our summary table of 165. Okay, so now that's how we summarize, numerically at least, quantitative data. So how do we summarize categorical data? It would not make sense to come in and take a look at your general health and find the average between good, very good, excellent. I mean, what do? We add all those words together and divide by the number of words? That doesn't make sense, okay? So there are other ways of actually summarizing categorical data. In particular, excuse me, we do counts, we do tables. So let's take a look at the Smoke 100, and let's go ahead and generate a table of the Smoke 100. Okay, so remember again, Smoke 100 is they smoked 100 cigarettes in their lifetime. Okay, so we'll type in the command table, and then we'll put in CDC, and we'll put in Smoke 100. And what that did for us is it came back with how many yeses and how many nos. So we got 10,559 no's that I've not smoked 100 cigarettes in my life, and we've got 9,441 yeses that I have smoked that many in my life. Okay. So one of the things that we would like to do is we'd like to come in and actually make a plot of that. In other words, we'd like to take a look at that in some way that makes more sense. And categorical data, one of the most common plots that we use for categorical data is a bar plot. It's basically take the categories on the horizontal axis, and on the vertical axis we take the frequency. So a bar plot, or a bar chart as it's referred in some places, is a really handy way of taking a look at categorical data. So we want to do that, but we have to be careful, because what we want to do is we want to do a bar plot of the table. We do not want to do a bar plot of Smoke 100. That would really not work out well for us, okay? Don't do it, just trust me. So whenever you're doing a bar plot, it's a bar plot of the summary of the data. And the summary of the data that we would use with categorical data is a table. So we can go ahead and come in and say bar plot. And now I got to nest the command, put in the table command, and then put in what I want the table to be. So I can put CDC and then Smoke 100. Okay. All right, now if I execute that, let's come over here and zoom. Notice it put it over in the plots pane off to the right. If I click on zoom, it'll give me my plot in a much larger size. And notice that what I have is a bar plot of 0 and 1 for my categories, and on the vertical axis I have the frequencies. Okay, so as we've sort of started to look at already how to gussy these up a little bit, we could come in here and we can say xlab equals 0 equals no, 1 equals yes, and then we can go and do a ylab. ylab equals frequency. I'm just going to say freak to make my life a little quicker here. Oops, forgot to put the parentheses in. Excuse me, not parentheses, quotations. Categorical variables have to be put into quotations. Boy, okay. And then main, we'll put in and give it the title, and then Smoke 100 cigarettes. Okay, so now when I do that, notice that I get the labels. Let's go ahead and look at the zoomed version of it again. Much more informative, tells me a lot more about what's going on. And one last thing, if I really want to, hit the up arrow again. That's a really important thing. Up arrow replays the command so I don't have to type the whole stinking thing over again. I can also go comma, col equals blue, let's say. Now, there are lots of other things I can do to fancy this up. I can get rid of the zeros and ones and actually put a yes and no there, etc. We'll talk about that later, but for now, that's pretty ripping. Good start at getting our stuff going here. Okay, now one thing that they talk about in the lab, and I want to go over here with you, is the idea of assignment. We've talked a little bit about that if you've watched some of the previous stuff. And assignment is important. What it does is it allows me to assign my own numbers into a variable, or I can assign output into a variable too. So for example, I can say smoke, as they do in the lab, and then in the lab they're going to use the left assign. Okay, you don't have to use the left assign, as I've stated before. You can use an equals. I think that's a little easier to type. And then I'm going to put in table CDC $ smoke 100. And now what that did is it just assigned that table into the variable smoke. In fact, if I echo smoke back to the screen, notice it just gives me back the table. Now the handy thing is if I'm going to be using that table over and over again, now I've got it put someplace where I don't have to keep typing table CDC smoke a gazillion times, okay? So again, if I just come in and do bar plot smoke this time, notice it gives me the bar plot right away because smoke contains the table. That's going to end up being handy at times, okay? All right, let's go take a look at exercise 2 here. It says create a numerical summary for height and age and compute the interquartile range for each, compute the relative frequency distribution for gender, and exercise any. How many males are in the sample? What proportion of the sample reports being in excellent health? Oh, like tomatoes, they're asking us a ton of things, okay? So let's go ahead and do that. So we want a numerical summary of height. So how would we do that? So we go summary, and then we would go CDC, and then height. Okay. And so that's a numerical summary for the height. Okay, we're going to do the same thing for age. I'm going to go ahead and hit the up arrow and save myself just a wee bit of typing here. Okay, let's take a minute and let's talk about what this output says. So on the height, it says the minimum height was 48 inches, the maximum height was 93 inches. The average height given by the mean was 67.18 inches. The average height given by the median is 67 inches. When we take a look at the age, the minimum age was 18, the maximum age was 99. Yay, somebody lived 99 years, that's awesome. The median age was 43 years of age, and the mean age was 45 years of age. Okay, so one of the things we're going to be talking about in this module is robust statistics. And one of the things that we notice here is it appears in the height data that the mean and the median are very close to each other, where in the age data, the mean appears to be substantively larger than the median, okay? Remember what that tells you. That tells you something about the possible shape of the distribution. I would be surprised to see if this data set for the height was not symmetric bell-shaped. In other words, that's probably bell-shaped or unimodal symmetric, where the age data is probably going to be skewed to the right. And what we see here is that the mean and the median are telling us that. If the mean is to the right of the median, then it's fairly likely that we have a skewed data set, okay? Something to keep in mind for perhaps the discussion question. Okay, so what else did they ask us to do? Okay, so they said also give us the interquartile range for each of these. So one way of doing that is to simply take those numbers and do the arithmetic, or you could get fancy and do IQR and do the IQR of CDC by height, okay? Comes out to be 6, and then let's do the interquartile range for CDC, and then we will do that also for age, okay? So the interquartile range is a measurement of variation. It's one way that we measure variability in a data set. So in this section, we actually start looking at box plots, and box plots one way to display the interquartile range, because the width of the box is the interquartile range. Okay. All right, so next thing they ask to do is compute the relative frequency distribution for gender and exercise any. Okay, so we need to do that because I actually forgot to do that back up with the smoke data. So let's go ahead and do the relative frequency ones. So let's calculate the relative frequency plots, or excuse me, data. So to do that, we simply take the table and we divide it by 20,000. So let's create a table for CDC, and they ask us to do that for compute the relative frequency for the gender. So let's do gender first. So CDC gender. Okay, so to create a relative frequency table, we simply take the frequencies and we divide it by the total, and the total being 20,000 here. So that tells us that there is a slightly higher percentage of females than there are to males. If I did not do the division by 20,000, I would get back the raw counts, how many males and how many females there were. By dividing by the 20,000, it actually gives me back the percentages. There's about 48% male and about 52% female in the distribution. Okay, so let's do the same thing in where is it? Exercise, an exercise any. Okay, so an exercise any. So we're going to go CDC. Oops, my bad. Sorry, go to table first. So table CDC, just showing you that, you know, this stuff does take a bit of thought sometimes to make it all work. And then let's divide that by 20,000. Okay, so it appears that, hey, that looks good. It looks like about 75% say that they have exercised some, I believe it was in the last week, or that last month, I forget that exactly, and then about 25% said they have not. Okay, it says how many males are in the sample and what proportion of the sample reports being in excellent health. Okay, so there are, again, the raw count for the number of males. There are 9,569 males, and then the proportion of the sample that reports being in excellent health. Well, to do that, we're going to have to go table CDC, and then we're going to go gen health this time. Okay, not gender, general health. So it's gen H. Okay, and then we're going to divide that by 20,000. Notice it doesn't have to just be a yes, no, or true, false, or male, female. You can have as many categories as you would like, and it'll give us back the distribution of those. So it appears that about 23% report being in excellent health, 34 or 35% report being in very good health, 28% in good health, 10% in fair, and 3% report back being in poor health. Again, that's a very, very handy tool to have when you're analyzing categorical data. Okay, so let's go ahead and finish up exercise 2, and then we're going to take a break and we're going to come back for exercise 3. Okay, so the table command can be used to tabulate any number of variables you provide. For example, examine the particulars for smoked across gender. We can do the following. Okay, so let's go ahead and do that. So let's take in, and we're going to take a look at table. And we're going to do compare CDC gender. Comma, and we're going to take a look at CDC smoke. My bad. CDC smoke 100. Okay. Now, this is referred to as a 2A or a contingency table. And a 2A table means that what we're doing now is we're taking a look at a comparison of two categorical variables and how they relate to each other. It could be that there are additional levels to each of the variables. Right now there are only 2 levels for each of the variables. The first variable is gender and the second variable is smoke 100, and within each of those we have 2 levels to their variable, either yes, no, male, or female. and so we end up with 4 cells in the table. The number of levels of the variable for each of those, you take the product of the levels, and that tells you how many cells are going to be in your table altogether. Think about that for a little bit and make sure that makes sense to you, okay? All right, so if we take a look at this, what it tells us is that we know that 0 is not smoked at least 100 cigarettes in their lives, 1 has. And we see that there appears to be a relationship between gender and whether or not you smoked 100 cigarettes. There were 4,547 that said no in the males, and there was 6,012 that said no in the females. There was 5,022 that said yes in the males, and there was 4,419 that said yes in the females. Now again, we can break those up into percentages, but let me skip that for the moment. That's going to take a little bit more than what I want to do at the moment. But what I do want to do is I want to make a plot of that. So the plot that I'd like to make of that is referred to as a mosaic plot. And it's basically a two-way bar plot. So let's go mosaic plot, make sure I'm spelling that correctly. Yes, I am. Let's open the parentheses. Let's close the parentheses. And when I hit an enter, oh no, I did not spell it correctly. I said I did, but I did. Oh, so I am what we refer to in the business as dyslexic. There we go. Mosaic, right? Mosaic. Okay, so that should work. Let's take a look. Yep, there it is. Let's go ahead and zoom in on that plot. And what that did is that gave me a bar plot that, make that, expand that out a little bit, that displays graphically what we showed in our table. So males that didn't smoke versus male that did smoke, we can see that the area of the bar for smoke is bigger than it is for didn't smoke, and then for females we see the area of the bar for didn't smoke is bigger than the bar for did smoke. Okay, all right, so you could, again as before, we could accomplish this in 2 steps by making it the table that we did back up here. In other words, taking this table, storing that into a variable, and then doing the mosaic plot command. Okay, so that's enough for part 1 of this of this lab. I'm going to go ahead and take a little break here. So if you need to, go back and review this, and then we'll come back for part 2 where we start talking about quantitative data.